Hey everybody, it's Miss A. Welcome back to Math in Minutes. This is a follow-up video to our previous video from 2 days ago about partial products. Alright, so what we learned with partial products is basically there are three rules. First rule is to expand. Second rule is to multiply. And the third rule is to add the parts. So expand numbers, multiply pieces, and then add parts. So our lesson or instruction for today basically took this same principle and just extended it one more step. So we started off with, and this is traditional partial products with multi-digit by one digit. So we had, let's say we had 6 times 31. All right, this is what we did previously. I just want to review that. So the first step is to expand a number. We expand our larger number. So 31 is equal to 30 plus 1. Second step is to multiply. So this is 30 plus 1. Second step is to multiply times 6. And I always tell my kids, write out your multiplication expression so you don't get confused. Times 6 goes across the row, and then whatever's on top goes down. So this one would be 30, and this one would be 1. And now I have mental math multiplication that I can do rather quickly. 6 times 3 is 18, and there's 1 0. 6 times 1 is 6. Next step says to add the parts. So I expanded, multiplied pieces, now I'm adding parts. 180 plus 6 equals 186. So that's what we did previously. So let's talk about what we did today. So we talked about multi-digit multiplication using partial products. So let's talk about 79 times 431. Now this is a really big number. We didn't do these type numbers. We did double digit by double digit, but I just want you to get the understanding, the kids to get the understanding that this partial products can extend to how many ever digits we multiply, and we will be multiplying up to 4 digits. So step 1 says expand. Before we expanded one number, now we have to expand both numbers. So 79 is 70 plus 9, 431 is 400 plus 30 plus 1. So we're going to need a bigger box. 1, 2, 3, and then 1, 2. I did 3 because there's 3 digits here, and I did 2 because there's 2 digits here. So 430 and 1, 70 times and 9 times. So now I'm going to write across, because second step says to multiply pieces. I'm going to write across 70 times all these boxes. And then I'm going to write across 9 times in all these boxes. So I follow the row across, then I'm going to go down, down, down. 9 times, 9 times, 9 times. Now down, that's 400, and this is also 400 because it's in that same row with this number. 30, 30, 1, and 1. All right, so now that I've done that, I can actually multiply my pieces. Excuse me. I'm going to underline all my zeros here so I don't lose a 0, because that tends to be a mistake that kids make, is they lose some zeros sometimes. So their mental computation is fine when it comes to multiplying their numbers, but sometimes they get confused with zeros. 7 times 4 is 28, and I have 1, 2, 3 zeros. 1, 2, 3. 7 times 3 is 21, and 1, 2 zeros. 7 times 1 is 7, and 1 0. 4 times 9 is 36, and I have 2 zeros. 9 times 3 is 27, and I have 1 0. 9 times 1 is 9. And now just a little reminder, the trick, for those of us that don't know our nines tables, this is a trick that can be used. Use it if you got to use it. Like, I mean, I get some teachers don't want to see their kids use it, but I would rather see them do this than draw out tally marks. So if I have 9 times 4, I always start from the left, move towards the right. 1, 2, 3, 4. I put the 4th finger down because it's 9 times 4. Hopefully you can see that. I'm not even looking at the video. Everything prior to this finger, these are my 10s. 1, 2, 3 10s, that's 30. Everything after this finger on both hands are my ones. 1, 2, 3, 4, 5, 6, 36. 9 times 3, 1, 2, 3, finger down. Everything before, tens, 20. Everything after, 1, 2, 3, 4, 5, 6, 7, 27. And then obviously 9 times 1, put down my first finger because that's 1. Everything before is my tens, 0. Everything after, 1, 2, 3, 4, 5, 6, 7, 8, 9, is my ones. So now that I have multiplied my pieces, I can add my parts. 28,000, 2,100, 70, 3,600, 270, and 9. And I want you to see how I lined up my numbers. 0, 0, 0, 0, 0, and 9 is 9. 0, 0, 7, 0, 7 is 14. Regroup my 1. 1, 0, 1, 6, and 2, that's 8, that's 10. Regroup my 1. 1 and 8 is 9. 2 more is 11. 3 more is 14. Regroup my 1. And 1 and 2 is 3. So 79 times 431 is 34,049. Now, that is just showing you how partial product works. But there was a second component to this, and it was estimating your value. So if I had 79 times 431, and they would be asked to do this first. They are to round these numbers first to get an estimated value to then see, is my actual value close? So the 9, rule for estimating, 0 to 4 stays the same. 5 to 9 goes up 1. And the kids saw a little video today, which was like this. So think about it as a car driving up a hill, a little toy car. The little toy car is going to drive to this number. So here's my little toy car. Really bad toy car, but there it is. And it is traveling to this number, and it will stop at the number. If the little toy car stops here, it's going to go this way. Gravity's going to take it this way. Gravity always works. Gravity will take it this way, which means it needs to go up. So the 9 is telling the 7 to go up 1, which means 80. Now let's look here. 431. So the 3, the little car is going to go to the 3. It's going to stop here. Gravity is going to take over as well, and it will go here, which tells it to stay the same. So the 4 will stay the same. So now I have a mental math computation that I can do rather quickly. 8 times 4 is 32, and there's 1, 2, 3 zeros, 1, 2, 3 zeros. That's 32,000. The actual number is 34,000. That's pretty close. So this is a rounding piece that they've put in there that the students will be asked to do. Just think of the car, guys. If you have to, draw out the little car, draw out the hill, and put your little dot, and just look. If it's up here, it's going to go this way. Any number past 5 will go this way. Any number past 4 will go this way. And don't put a number at the top of the hill, because that means it's going to stay still. And there's nothing staying still. So look at where the top part of the hill is, and then start the 4 on the right, the left. Start the 5 on the right. This is the top of the hill. And that's where everything would stand still. But this is an added piece that they're talking about. Again, this is not new to the students. They've talked about mental math multiplication, so that's not new. We've talked about rounding. We've done it several times. I definitely need kids to learn how to do it correctly. And this was the component that we added, the second expanded. So we had these exact same rules, except yesterday it was expand the biggest number. Today it's expand both numbers. All right, so let's look at another example. So the first thing it's going to say is estimate 64 times 38. And then solve using partial products. All right, so the first step is I need to estimate. So I have 64 and I have 38. If this helps, draw it out. 4 tells the sticks, so here's my little hill. 4, 3, 2, 1. 5, 6, 7, 8, 9, 0. All right, the 4 is on this side, so it stays the same. So 64 rounds to 60. 38, the 8 is on this side, so it goes up. So that's 40. 6 times 4, 24, 2 zeros. So I have 2,400 as my estimated product of 64 and 38. Now we need to solve using partial products. So rule 1, expand both numbers. 60 plus 4. 30 plus 8. And I always like to put times there. Actually, my friend Alex in class showed this, and I'm like, that's a really great way to remember you're writing this number in each box times. So now I'm going to write out, because my second rule says I need to multiply. I'm going to go across in the boxes. 30 times, 8 times, 8 times. Now down, 60, 60, 4, and 4. And I'm underlining my zeros first so I don't forget any of them. I don't want to forget a 0. 3 times 6, 18, 2 zeros. 3 times 4, 12, 1 0. 8 times 6, 48, 1 0. And 8 times 4 is 32. Now I will tell you, a lot of kids understand this concept. They understand how it works. They understand how to expand. This is where they make a mistake. They don't know their multiplication tables. It is imperative that children at this age learn and memorize their multiplication tables. It needs to happen. Strategies to solve multiplication only work as well as you know how to multiply. Now I'm at step 3, which is to add my, I multiplied my pieces, I'm adding my parts. 1,800, 120, 480, 32. And it doesn't matter what order you put these numbers in. I usually start here and go across and then go across. It doesn't matter because adding is, you can put it any direction and still get the same answer. 0, 0, 0, 2, 0, 2, 8, 3, 13, regroup a 1, 9, 10, 10 and 4 is 14, regroup a 1, 2,432. And if I were to round 2,432, that would actually round to 2,400. So that one was really, really close. This was a really good estimate. This was a good number. So this is how we handle multi-digit multiplication using partial products. So now I'm going to give a couple of practice problems. Remember, it is to estimate first and then solve. And for 4th grade, I understand that some kids know how to multiply just using standard multiplication. And on the assessments, I don't care how they multiply. It's their choice. They pick a strategy and they use it, and I'm good with that. For the particular lesson and the daily assessment, our standard says that they have an understanding of multiplication strategies, so I am assessing whether they can do the strategy. Now, after the daily lesson, I don't care what strategy is used in order to solve. So just keep that in mind, that yes, for the daily lesson, when I give them the exit ticket, I am looking for, can they use this strategy and get it right? But come assessments, come the test for the unit, come the test for the chapter, come FSA, I don't care what strategy they use as long as they get the answer right. That's the point of that. So, 47 times 31, 86 times 29, 17 times 134, and 38 times 46. All right, so those are the practice problems. I hope this video helps. Thanks for watching, everybody.